Welcome to SD Civil Info. This session is going to be about types of loads acting on structures. What is load? Load is a weight or source of pressure borne by someone or something. And construction loads are defined as loads imposed on a completed or temporary structure during and as a result of the construction process. For construction of building, we have to consider two major factors. They are safety and economy. If we consider only loads as a higher priorities, then the economy of the project may get affected. And if we consider economy as a higher priority and the loads are not taken into consideration, then the safety is to be compromised. Different types of loads that acts on a structure can cause stress, displacement and deformation on a structure, which results in structural problems and also even structural failure. Hence, determining the total load acting on a structure is very important and complex. And so, the structure should be designed in such a way that it should be enough strong to bear any type of load at any time that they are likely to face during their life cycle. Hence, the estimation of total load that acts on a structure or the total load that is going to be acted on the structure in future is to be calculated accurately, and the same should be designed. Here, the various design loads for building and structures are specified in the Indian Standard Code IS 875-1987 and American Standard Code ASCE 7 Minimum Design Loads for Building and Other Structures. The different types of loads acting on structures are broadly classified into the following types. They are vertical loads and horizontal loads. These types of loads include dead load, live load, wind load, snow load, earthquake load, and special loads. Let us see one by one. What is dead load? The first vertical load that is considered to be acted on a structure is called dead load. Dead loads are permanent or stationary loads and which are transferred to the structure throughout its lifespan. And dead load is primarily due to the self-weight of structural members, permanent partition walls, fixed permanent equipments, and weight of different material that exist on the particular structure. The permanent parts of the buildings are like weight of roof, beams, walls, and columns, etc. And the dead loads of each structures are calculated by the volume of each section get multiplied with their unit weight and is given in IS 875 Part 1 1987. For example, in the given figure, the column is made of reinforced cement concrete and having a length and breadth of 0.4 meter and a depth of 3 meter as shown. First, we have to calculate the volume of concrete, that is length into breadth into height, that is equal to 0.4 into 0.4 into 3, that is equal to 0.48 meter cube. The dead load of the column is obtained by multiplying the volume of concrete with the unit weight of reinforced cement concrete. That is, we know that the reinforced cement concrete's unit weight is 25 kN per meter cube. Therefore, the dead load of column is equal to 0.48 meter cube into 25 kN per meter cube, that is equal to 12 kN. Therefore, the dead load acting on a column is equal to 12 kN. Next one is live loads. What are live loads? Live loads are also known as imposed loads or sudden loads. These are either movable or moving loads without any acceleration or impact, and these loads are assumed to be produced by the intended use or occupancy of the building that includes weight of movable partitions or furniture, etc. These live loads keeps on changing from time to time and are to be suitably assumed by the designer. Live load is one of the major load in the design process, and in IS 875 Part 2, the minimum values of live loads to be assumed are given in detail. and it depends upon the intended use of the building. These codes give the values of live loads as uniformly distributed load as well as concentrated loads for the following occupancy classifications. They are residential buildings, educational buildings, institutional buildings, assembly buildings, business and office buildings, mercantile buildings, industrial buildings and storage buildings. In case of dead load, the load calculation is based on each and every individual member of the building, whereas for live load, the load calculation is based on expected sudden loads on the buildings in future. And the next type is wind load. If the height of the building is more than 15 meters, these types of loads are considered in design. And wind loads are occurred due to horizontal load caused by the wind. As there is an increase in the usage of lighter materials in the construction, wind load for a building must be properly considered, and the structure should be strong enough to withstand the heavy dead weight and must be anchored to the ground to resist this wind load. And the calculation of wind load depends on the two important factors. They are velocity of wind and size of the building. And the details of calculating the wind loads on structures are given in IS 875 Part 3, 1987. To get the design wind velocity Vz, the following expression shall be used. Wind velocity Vz is equal to K1, K2, K3 into Vb, where K1 is the risk coefficient, K2 is the coefficient based on terrain, height and structure size, K3 is the topography factor, and Vb is the basic wind pressure that is shown in a map of India. Designer can pick up the value of Vb depending upon the locality of the building. And now, to get the design wind pressure Pz, the following expression can be used. The design wind pressure is equal to 0.6 Vz square, where Pz is in Newton per meter square at the height Z and Vz is in meter per second. Now, the wind pressure is considered to act uniformly up to a height of 30 meter, and above 30 meter height, the wind pressure increases. The next one is snow load. Snow load is also a vertical load in the building, but these types of loads are considered only in the snowfall places, and these loads are calculated by the projections made by snow at different parts of the structure. The amount of snow load depends on the height of the building, size and shape of the roof, the location of the building, that is, whether it is on the slope or not, and the frequency of snow, etc. And the more details about snow loads are clearly mentioned in IS 875 Part 4, 1987. And the minimum snow load on any area above the ground or roof area which is subjected to snow accumulation is obtained by the following expression, that is S equal to mu S naught, where S is the design snow load, mu is the shape coefficient and S naught is the ground snow load. The next one is earthquake load. These types of loads cause movement of the foundation of structures, and these forces are the internal forces that developed on the structure because of ground movement, and these earthquake forces constitute to both vertical and horizontal forces on the building, and the total vibration caused by the earthquake may be resolved into three mutually perpendicular directions, usually taken as one vertical and two horizontal directions. And here, the movement in the vertical direction do not cause any forces in the superstructure to any significant extent, and so the vertical force doesn't affect much during earthquake, but the two horizontal forces cause movement of the building at the time of earthquake, and hence these two horizontal direction forces are considered in the design. And the IS code 1893-2016 give the details of such calculation for structures standing on soils which will not considerably settle or slide appreciably due to earthquake. In order to compute the seismic forces acting on a structure, one of the below mentioned methods are to be followed. They are response spectrum method and seismic coefficient method. Now let us see what are the special loads acting on a structure. In addition to the above loads discussed, as per the code IS 456-2000, there are some other types of forces or loads that act on a structure and they are liable to affect materially the safety or serviceability of the structure. They are foundation movement, erection load, elastic axial shortening, vibration, fatigue, soil and fluid pressures, impact and stress concentration effect due to point of application of load. And finally, we come to the end of this session. In this session, we have seen the types of load that acts on a structure. If you feel useful by watching this video, please do like, share and subscribe. Thank you for watching.